Hello everyone. I'm going to go over a problem that I encountered when I was subbing at the private school on Friday. And I was, during my conference period, I was subbing English. Normally I do just math and history is what I prefer. But I was subbing English and I got to do a little bit of Shakespeare. That was always fun. And I went upstairs to go talk to the chess coach because we hang out and we goof off on chess a lot when I'm there. And we didn't get to play chess because we were focused on this Math Olympiad problem. Now, the Olympiad problems are, there we go, that's working, is a test that students take, high school students, I believe. I never was a Math Olympiad coach or anything. My background was mainly freshman math. Sometimes I taught sophomores in Algebra 2 and juniors in pre-cal. But I never got into the testing stuff. I was just focused on the teaching stuff. So what this Math Olympiad test is, it's about 40 or 45 questions, and you got about 40 minutes to do it, and it's no calculator, so this is no calc, all right? And so these problems are designed to where you can work them pretty quick if you know your definitions very well. Well, this was thrown at me by a teacher, by the by the physics teacher, who's the the chess coach. And I'm sitting there looking and going, I don't know how to do this problem. But something was bugging in the back of my brain that I've seen something like this before. I could not place it. So I was going nuts always over it, trying to think, and I was looking for shortcuts, and I saw this over here. I said, 3, 6, 9, 12, maybe there's a pattern there. I was looking at patterns. I don't know who did this writing. This was copied from the test that I just took a picture of. And I wasn't sure. We were talking about it for the longest time. And then on the drive back at the end of the day, it hit me. I've seen this in my math degree. I never encountered this in my teaching. And whether it was, I taught a couple of years of Algebra 1, 1 year of pre-AP Algebra 2, and a couple of years of pre-cal. But I was mainly a geometry teacher. I love geometry. And I never saw this ever. And I gave my kids a lot of SAT problems, especially my freshman pre-AP and GT geometry students. They would get a weekly test on SATs. And I would draw from old tests from 80s, 90s in recent tests because it was a weekly test and I had to have a lot of problems. I never once saw anything like this. But then it came to me. I remember seeing something like this in my freshman computer science class when I was at University of Hawaii. And I'm going, it was a base 2 problem, though, converting to base 2. Because if I remember right, and I barely remember it, it was punch cards and basic A. We had to convert stuff to base 2 sometimes. And so I came home, looked at it, looked online, did a little bit of homework, and I said, this isn't that hard of a problem at all. So let's go ahead and figure this out. So first of all, let's talk about our numbers. So I'm going to make up a number, 2,467, all right? Now, this is a base 10 number, and I never thought about it until today that we would subscript, like base 10. And I also thought about logarithms. And logarithms, I said, maybe there's a way to do it with logarithms, but no, this is just a basic number problem. So what we have here is this 2 in the thousands place is 2,000, or 2 times 10 to the third. And this 4 is in the hundreds place, so this is 4 times 10 to the second. This 60 is in the tens place, so that's 6 times 10 to the first. And the 7 is in the ones place, so that is 7 times 10 to the 0 power. And that's how we would write this, expressing it kind of like a base 10's expanded out number. So I have dealt with different bases before, but not in the context of like this kind of problem. Because every year I talk to my students about the Babylonians on how they used a base 60 system. I mean, that's how we got 360 degrees in a circle, all right? It's from the Babylonians. And, triangles are 180 degrees because you got 3 chords that are joined at the vertices. And that creates our 180 sum of the interior angles of a triangle, and so on. So a lot of plane geometry, well, I would think almost all plane geometry is based off the circle and its definition of 360 degrees. So it's really, really cool stuff. But when I was looking, trying to figure out how to do this and explain it, I ran across that the mines use base 5 and base 20, and there's a lot of advantages to that. And at the end, if I remember, I'm going to, on my last slide, talk about Numberphile, YouTube channel that I subscribe to. That the guy is so smart. Oh my gosh. Anyway, but we have different number systems that we don't even realize that are still legacy today. There's a tidbit down below about the British. Okay, so first step in solving this problem. Now remember, this is a Math Olympiad problem, so it's meant to go fast. You shouldn't spend more than 20 or 30 seconds on this. Well, I'm not going to. I'm going to go a little bit longer than that. So let's convert this whole thing to base 10. I'm going to start off with this part right here. This is in the what we would call the hundreds base in base 10. So this is going to be nothing more than 8 times 9 to the second. All right, so that's in the 81st place, basically, plus 8 times 9 to the first, plus 8 times 9 to the 0. Now, I am lazy, and this is a Math Olympiad, and I'm not going to do 8 times 81. That's too much for my brain, all right? I'm stressed. I'm taking a test. I'm going to factor out the 8, okay? I'm going to have 81 plus 9 plus 1. I just factored out the 8, okay? I can do, because this is just 91, I can do 8 times 91 in my head. 8 times 90 is 720, so 729. Sorry, 728, okay? So that's pretty easy to do. So that's 728. Then I need to add this. This is nothing more than 5 times 6 to the second, plus 5 times 6 to the first, plus 5 times 6 to the 0. Okay? So that's 36. Again, I'm going to factor it out because I can't do too much math in my head, tell you the truth. Plus 6, plus 1. All right? So that's 42, 43. I can do 5 times 43 in my head. All right, that's pretty easy. That's 215? Yes. All right, 215. I hope I didn't get that wrong. All right, if I did, shame on me. Oops. All righty. And then the last one's going to be a little easier. That's 2 times 3 to the second, plus 2 times 3 to the first, plus 2 times 3 to the 0. So if I factored that out, 2 times 9, 10, 11, 12, 13, 2 times 13, okay? And that's going to equal to 26. And then I just add these up. 728, 9, 30, 34. It is 969. 969. And this is base 10. We don't write our base 10s, just like we don't put 1s in front of our x's and 1s to the power of and things like that. So 969. I knew it was 969 because I did this earlier. I did this problem twice, actually. Okay. I even wrote it here. I forgot I wrote it here. Okay. Now, we're going to convert this to base 12 because that's what our answer is supposed to be. Now, let's don't forget that we are going to do the 12 times 12. So this is the 12 squared place. This is the 12 to the first place. And this is 12 to the zeros place. So 12 squared is 144. How many groups of 144s goes in the 900? That's all it is. It's like a 969. How many groups of 10 go in the 900? All right. So, how many groups of 100 go in the 900? There would be 9 of them, right? How many groups of 60? How many groups of 10 go into 60? Well, that would be 6. How many groups of 10s go into 9? That would be 1. So we're going to do the same thing for base 12. How many groups of 144 go into 900? Now, that would be 6 times 144. 600, so yeah, 6 times, all right? Now, actually, this being a Math Olympiad multiple choice question, I think this one was 1, 1, 1, 1, choice D was 1, 1, 1, 1, all right? And I would know instantly the choices B and move on to the next problem. I wouldn't have to go any further, but I did, all right? So let's see, 6 times that is 4. Carry 6 times 12. 4. It is 864. Good grief. My math is bad. Okay. 864, so that gives me 5. That gives me 2. No, that gives me 0. That's a 6. Good grief. That's a 69. Okay. Boy, I almost made a mistake. 105. All right. So now I have 105. This is in the second place. This is in this place right here. So how many 12s goes into 105? Well, not that many. I mean, that's going to be pretty easy to do. 8 times 12 is 96. I'm not going to get another 12 in there. So I know that I'm going to go in there 8 times. All right. So I'm going to subtract. That gives me a 9. And of course, I took away from that 9 0. So 0, 9. Now we're into the last place. How many 12s goes into 9? None. All right. So that's going to just be a 9. So my answer is 6, 8, and the remainder of 9. And that is base 12. That is my answer. That's how I convert it. Okay? So you can do this for base 8. Now here's another little tidbit. I went from base 10 to base 12. So the number's going to be smaller. So I could immediately struck out those two answers right off the bat. It would be between 582 and 689. And then once I started going, once I got the first digit of 6, I'm good. And I don't need to go any further for this test. I'm on to number 3, which was a rate change problem. It was pretty easy because it's based on 60. Hey, all right. Well, anyway, here is Numberphile. If you are interested in really wow stuff, this is a guy to go to on YouTube. This guy is incredible. Numberphile, he pops up on my YouTube every now and then. A lot of his videos are old, but they're just as valuable. So I highly suggest that. Alrighty. Well, that is all I have. I'll go ahead and get this posted to YouTube, and I'll post a link to his this video.